Well, hello everybody, and welcome to the first meeting on the Agentic Design Patterns. And today we're going to talk about prompt chaining. It was a quite short chapter, and the overall idea was that if we have a complex prompt, well, not even like very complex, but any prompt that kind of embodies multiple stages, that it makes sense to decouple these stages into separate prompts with separate outcomes. So for instance, in the book, they give us an example that like analyze a market research report, summarize blah, 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 identify, and then draft an email. And the idea is that first we would have an initial prompt to do the summarization, then we would have a second prompt to do trend identification, and then we would have the third prompt to do email composition. Lovely. It kind of reminds me of the kind of well-known software engineering principles. We don't have that many of them here, but like solid, so like single responsibility principle, make your prompt to do a single thing and do it well, right? Next, another thing that the authors propose is that since we're kind of composing multiple agents, multiple outcomes and incomes, multiple outputs and inputs, it makes a lot of sense to use structured outputs. For instance, here, when we ask the agent to produce trend identification, it makes sense to ask the agent to use JSON schema and to produce trends in the structured output format. And it kind of maps to L in solid, I guess, ish. Don't judge me very harshly on the solid principles, please. And I was hoping that by the end of the chapter I would have all 5 letters of solid, but sadly that was kind of it. So we have SL without OID. Nevertheless, moving on. So 2 principles: decompose your large prompt into smaller prompts, use structured outputs. Lovely. By the way, a bit later on, we will have a look into how different frameworks that enforce structured outputs compare, but that's going to come later. And we have a few examples. So the prompt one, I believe that this is one of the prompts that tries to analyze the content, right? So we extract text content from a given URL. Well, basically the idea of the decomposition, right? So extract something, summarize, extract something else, use entities, blah, 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 blah. Nothing new. What really matters here is that if we compose multiple small but well composed prompts, we're basically composing multiple generators, well, not classifiers, right? Kind of multiple generators, right? And if one of the generators, if we can make even a slight positive nudge in the reliability of each one of these components, each one of the agents, it makes a huge impact. For instance, if we had only 5 complex prompts, that would give us fairly good output, probability of being correct, right? So we know that LLMs hallucinate. So if we have 5 components that give us probability of being like doing the correct thing in the end of 0.95, which is a fairly good probability, right? And we have only 5 of them. Then since we feed the output into the input of the next agent sequentially, we multiply the probabilities, right? So, and the end result is 0.77. And if we decompose each one of them into 2 smaller prompts, and it makes it 10 stages, right? But each one of them, we make only a slight nudge towards like the more reliable outcome, 0.98. The end result, surprisingly, is better. And we made the increment only of 3% of reliability, right? So, I thought that the numbers would be worse, but as we can see, it makes a lot of sense even from the probability and stats perspective. We have a few more prompts in the book. I think that in these prompts, the peculiar thing that we can remember is that sometimes, and probably, I guess quite often, a good idea would be to add human input into the prompt chain. So for instance, one of the prompts would generate 5 topics, and then we would ask for human feedback right here. So like allow users to select one idea. Well, I think that they have a fallback to automatically choose the best one, but I think it's just something we can remember, that it makes sense to ask for user feedback, and I guess it makes sense to ask for user feedback not only to choose something, but also to verify the output of the generated stuff. And I think another prompt, well, let's see. I added it for a reason, I guess. Well, I think it was just another idea of how we can apply the decomposition to the code. So, for instance, we could ask to first understand the request, write the first draft, and then kind of do the self-review. So LLM would kind of pick up its own errors and self-correct, in a sense. And here's a code that we've been given in the book that gets us from the pure theory to something applied. I cleaned it up a little bit, and we can see in practice that we have 2 prompts here. One prompt to extract the data from text input, then another prompt is to transform the output. Well, I guess it's a way to transform the specification into structured output. So we're basically kind of decomposing the extraction and structured output thingy into 2 separate tasks. And this is how we create a full chain of them. So we have the first extraction chain, which is composed of the prompt, our large language model, and the stringified output, and we compose 2 chains together. So yeah, I guess the final output should be that this is like CPU is 3.5 gigahertz, and we have RAM of 16 GB, and etc. and etc. Lovely. And as an overview picture, roughly it looks like our flow now looks something like this. So we have well, multiple prompts that we can, well, I guess here we do them in parallel, but it's not necessarily in parallel, right? So sometimes we can do multiple prompts in parallel, feed them to a single agent, and then do summarization. But I guess a better flow that we saw in this book would be to sequential composition of the agents, and then get the final outcome. And just to remind that this thing that we kind of overviewed right now, it's called prompt engineering, and we also touched base on the structured outputs, and it's only a tiny part of the thing called context engineering, which embodies not only how we compose the prompts and how we do the parse the outputs, but also how we do memory, how we feel the context of our LM, and etc. and etc. And the thing that I wanted to dive a bit deeper on is structured outputs. So we've been proposed to always use structured outputs, but the question is, how do structured outputs, specifically in form of JSON, maybe in any other form, affect the performance of the LLM? I mean, did anyone ever had a question like this? I mean, did anyone ever try to measure the reliability, the hallucination rate, or even just the plain performance on some benchmarks of LLM with different structured outputs?
Would structured outputs mean JSON too? With like
JSON
text?
structured, well, it can be XML, it can be I think a good baseline would be to just do some smart parsing of the free form output of LLM.
I tried. It was a very simplistic approach with a human in the loop. And also then when context windows increased, it was like another reviewer LLM in the loop. When I'm saying LLM, I mean LLM, so it wasn't an agent.
Mhm.
Uh, but what I understood, the reviewer LLM didn't solve the problem for the business just because the business people only trusted other people.
Okay, all right. Well, anyhow, it's been bugging my mind for a while, uh, because I saw with my own eyes in the reasoning chain that LLM spends some tokens uh, on thinking that, hey, I need to do the structured output, etc., etc. So I mean, it spends compute to do that, right? So inherently, it feels like it should affect the performance of the output. And I did a bit of digging, and here's what I found: that in back in 2024, there was a research that prompted GPT-4o Mini, which is not the biggest model, right? But still, it's still something. And they saw that performance on GSM 8 car dropped from 94% to 86, which is significant, right? Sadly, it's only a single data set. But next, it was a whole kind of a lot of drama and a whole battle of researchers and comparisons of different benchmarks. So there was another blog post uh, that showed that, well, they used a different model, a smaller model, but for a smaller model, Llama 3 8B instruct, they saw that uh, if you properly augment the prompt, then actually on GSM 8K, um, the model performed even better with structured output compared to non-structured output. And on different datasets, on different tasks, they also saw significant gains. Well, maybe not significant, but still gains, so at least it wasn't the same baseline. But then there was another independent replication, um, which came, what, only 1 month later, and then was updated half a year later, um, that confirmed the Llama results. But when they tried to do the same for GPT-4o Mini, uh, once again they saw that JSON schema collapsed. So I think we can safely conclude that there is no real universal answer for this, and it's very, very model dependent, and probably depends on how on which data the model was trained. But anyhow, I don't think there is like one single very good answer. There was a JSON schema benchmark which compared different ways of how we can enforce JSON schema, and we can see that well, lovely. One of the ways of how we can enforce JSON schema is better than the others, but they don't have a baseline without any JSON schema. So this LM only entry, it's the way I understand it, it's when they just ask LLM to answer in the structured output format and they don't do any kind of enforcement on this format. And all other methods, it's some way of masking logits. So whenever LLM outputs something, they kind of accumulate the result, and then based on the accumulated result, they mask the logits of the output. So for instance, if you um, um, saw a closing bracket, then probably you should see a comma right after, right? So you mask all other tokens, all other possible tokens. It should be either a comma or another closing bracket, something like this. So I don't think it gives us a very clear picture of how this structured output fares against unstructured output, really. And in theory, there were two other papers that showed that, hey, dudes, like when you use structured outputs and masking, like the distribution of the tokens is different and or something. Well, basically, these two papers, if you want to dive deep into theory, can give you some insights onto what happens to the legit distributions. But really, it's like, yeah, if we mask some tokens, I think it kind of makes sense that we have different distributions. Um, I didn't find any concrete numbers as to like with specific benchmarks there. Uh, but the guys there just proposed, like in one of the papers, proposed an algorithm that, hey, why don't we apply the structured output only for like structured output masking only after the reasoning chain, which kind of makes sense. And when they did that, um, they pretty much recovered the initial output distribution. So, well, I don't think it brings much to the table, but yes. So in theory, the output, the masking, and enforcing structured output affects the conditional distribution that LLM produces uh, when it tries to, well, when it generates the output. But how exactly, based on the empirical results that we had before, we don't really know. So it's still a mystery. Um, and this is really it. Do we have any questions?
Yeah, I really liked your idea with kind of trying to map what the guy says in the book to the solid framework. Do you have any guesses for now? What could be the other letters?
Um, well, we can try. We can try. Um, yeah, my brain is not braining right now. So I guess we can try to do the mapping later when we come go through next chapters. I think that would be better, really. But I think quite a few of them are going to come down to how exactly we're going to implement all the principles outlined in the book and not to the principles themselves.
Yeah,
Anything
let's
else?
do it. Yeah,
Uh,
while we are reading the book.
yeah, anything else, ladies and gents?
Thank you for the presentation. The discussion on the structure of the output was really valuable because I think it's usually taken for granted that we always need to use some kind of structured output, but it turns out that it can spoil the performance of our model. So yeah, it's interesting.
Thank you.
And yeah, but yeah, I agree that the content of the first chapter should have been just put into a few pages of the book instead of 15, or I don't remember how many was there, but yeah, uh, the information was a bit repetitive, I believe, in some
Yeah.
parts of it.
Well, if we don't have any other questions, let me stop the recording right now.